All right, one of the most common things you do with a loop is to keep a running total, like adding up all the test scores, right? Or opening a database, opening a file, and reading in all these values and adding them together, right, to calculate the total payroll or something like that. So, why don't we write a little app that will ask for an employee's hours worked and their hourly wage, and we'll keep doing that until they get tired of doing that, and then if they type in a -1, we will print out the total of all the paychecks. That'll be a pretty easy little app. So let's make a new one called Lecture Q. Getting my boilerplate. I guess I made a C++ app. That was not my goal. A C#. That was C#. That's why it looked a little bit weird. Add a new item. We're going to be a little bit strange today, just because we're feeling strange. So, I'm going to go ahead and make my lectureq.cpp file and paste my boilerplate in it. But then I'm also going to add a class to my program. So I'm going to click over here on source files, and I'm going to do, let's define it in the same file, just like we've been doing. We're going to create a employee object, and we're going to ask for the employee's payroll information, and then we will fill it into that. So class employee, and every employee has an hours worked, and every employee has an hourly wage, hourly pay. And these need to be public variables. So public colon. And so now, inside of Lecture Q, we're going to have a loop. So let's just say done, bool done equals false, semicolon, and we're going to do while, parentheses, or exclamation mark, not done, in parentheses, curly brace. So we need to create a payroll object, employee E. Good enough. Let's ask for the employee's hourly pay. But if they type in a -1, we're going to quit. So cout less than quote. What is the employee's hourly pay? Question mark, \n, semicolon, cout less than, or -1 to stop. Period. \n, end quote. Or let's take out the \n and just do space, space, greater than. They'll know where to type now. So let's read in the hourly pay. CIN, we need a variable to hold it, don't we? Or we could store it straight in the employee object. CIN greater than E dot hourly pay. But if they typed in -1, that means they want to stop. So if E dot hourly underscore pay equals -1 in parentheses, curly brace, then we set done equal to true because we're done. And we could just break out of the loop. It'd actually be the most efficient thing. In that case, we could have just made this a while true loop rather than mess around with any variable. I feel like making that change. I'm going to delete that bool done is equal to false, and I'm going to make this while true. And then if they type in -1, that we're going to break. Now let's get the hours that they worked. See out how many hours worked this week, question mark, or -1 to stop. And we've already asked them one time to stop. So anyways, \n, semicolon. Let's just copy this statement, see out or -1 to stop. Now let's let them type it in, and after they type it in, we're going to fill in that employee's hours. And we're going to check to see if it was equal to -1, and if it was, we're going to break. If E dot hours equals -1, then break. We don't even need these curly braces up here, so why don't we delete them from here as well? All right, now we can calculate their paycheck. Let's go add a method called calculate pay. So I'm going to scroll back up to my class and add a method. Whoops. And a method is just a function that's part of a class. So int space get underscore weekly underscore pay, parentheses in parentheses, curly brace, return, or let's be a little bit more thorough than that, int total equals 0, total equals this dash greater than hourly pay times this dash greater than hours, semicolon, return total. Right, and we could come back and we can make this more complicated and make it support, you know, time and a half for hours over 40. Wouldn't be too hard to do that. We're going to print it out, and then we may add it to a running total. Why don't we create our running total variable up here, our accumulator, as they called it in fundamentals? So int total underscore paychecks equals 0, semicolon. Now down here, after we get their hours and their hourly pay, we can calculate the current paycheck. Int space paycheck equals E dot get weekly pay, parentheses in parentheses. And we could add that to our total, but we may also want to print it out. See out less than print paycheck for $, end quote, less than paycheck, less than ENDL. And then let's add that to our total. Total underscore paychecks plus equals paycheck. There's a lot of stuff over here I don't really need. If I could squeeze this up and get a little bit more screen real estate. Yeah, whole line. All right. After the end of our while true loop, before our pause, let's print out the total. Total of all paychecks equals, end quote, less than, or let's put a $sign there. Total underscore paychecks less than ENDL, semicolon. Let's run it and see what happens. Now I did a lot of typing without ever running, and I'm surprised it worked without a syntax error. All right, what does the hourlies pay? This dude earns $10 an hour. He worked 40 hours a week, so he got a paycheck for $400. This next person earns $15 an hour, but they only work 10 hours this week, $150. Let's do one more person. The big boss earns $30 an hour. He works 1 hour a week. His paycheck's $30. Seems unlikely. Now -1 to stop. So the total of all paychecks is $580. So we had an accumulator variable. We had a running total. So what is the running total? I mean, maybe it's obscured by the fact that we added a lot of functionality here and we used a class, but it's just something that's initialized to 0. And inside the loop, it's calculated and added to. So all we did is we got a paycheck and we added to it. We just happened to store our data inside a class, just to get used to using classes. We could modify get weekly pay to support overtime, right? So inside get weekly pay, if this hyphen greater than hours is greater than 40, into parentheses, total plus equals this hyphen greater than hours minus 40, in parentheses, divided by 2, times this hourly pay. That's the time and a half formula. It's one expression of it. And I've had people argue with me about how you calculate time and a half pay, but this will probably work. Let's prove it. Let's run it one more time. If they work 10 hours at 50 hours a week, or let's just say for 41 hours, then they're going to earn $410, but then they're also going to earn $5 extra for time and a half. 410. Well, that didn't work. What did I do wrong? I'm not getting it. Paycheck is 10. They work 50 hours. 550. It's not calculating at a time enough. Maybe I didn't build it. I thought I did. I hate to get so stuck on something so simple. All right, I'm going to have to set a breakpoint and see what's going on. So I'm going to set a breakpoint right here. I'm going to run it. They work $10 an hour at 50 hours. It got here. Hourly pay is set to 10. Hours is set to 50. That's good. So we're going to step over, going to calculate the total. There we go. The total is 500. Well, maybe it was calculating it right all along and I was just spacing out. That sounds right. And then step over again. Tell you what, we're going to revise that a little bit. Yes, sir.
When I put it in, print paycheck for my print paycheck and total paycheck are the same thing.
I'll come look. Let's modify this calculation just a little bit. If that's their total pay, now let's calculate their bonus. Int bonus is equal to 0, semicolon. And then we're going to change this total plus equal to bonus equals. And then we're going to return the total plus the bonus. And I'm sure that's right. Run it. $10 an hour, 50 hours. So at 50 hours at $10 an hour, it would be $500. But they got a bonus. For an extra 10 hours. And for those extra 10 hours, they got a bonus of 1/2 10 times 5. All right, let me come over there and check. So if this is our code there, let's go down to our loop. And you're just going to do that part. You just weren't printing out the paycheck for the $sign accurately. Okay, so the question is, what in the world is this E.dot business? Well, that just represents the members of the class. We're going to make another class called Triangle. Triangle's going to have a height and a width. So class space triangle. Have we done a triangle class already? I tend to use the same examples. I always use a circle and a rectangle or a block and a triangle. Okay. A triangle's got two members. It's got a height and a width. So double space height, semicolon, double space width, semicolon. And what do we care about? We care about the area of the triangle. So double space get area, parentheses in parentheses. And the formula for the area of a triangle is 1/2 times the height times the width. So double space area equals 0.5 times height times width and return area. I'm going to go back and add this reference. So I'm going to, in front of height and width, I'm going to do this dash arrow and this dash arrow. So that's the height of this triangle, and this is the width of this triangle. And down in main, we're just going to create 3 triangles. And then we're going to get their areas. So above that int paychecks line, let's do this. Triangle T1, T1 dot height equals 10, semicolon. T1 dot width equals 10, semicolon. And let's make a second triangle. Triangle T2, semicolon, T2 dot height equals 20, semicolon. T2 dot width equals 20, semicolon. Why not a third one? I'm just going to copy and paste this time. Speed things up. Triangle T3. T3 dot height is equal to 30. T3 dot width, I cannot type, is equal to 30. Now let's print out their areas. Cout less than quote triangle T1 area is space end quote less than T1 dot get area parentheses in parentheses less than ENDL. And then just copy and paste that and change all the T1s to T2 and T3. T2 area is T2 dot get area. T3 area is T3 dot get area. And so the area of the 10 by 10 is 50, that's correct. The area of the 20 by 20 is 200, and the area of the 30 by 30 is 450. Those are correct. Hope that kind of makes sense. The class creates objects. Each object is a collection of data and the functions that use that data. Except those functions are called methods when they're attached to a class. So each triangle has a height and a width, that's the data. And each triangle has one function, one method called getArea. And so what's useful about a class is that you can hold more than one piece of data. You can write a class that contains hundreds of pieces of data, right? It can contain arrays and it can contain other classes, other objects. We could create a point class and we could define a triangle as a collection of 3 points. So there'd be a point class and then a triangle class, and the triangle class would have references to 3 points in it. All right, last thing is we're going to make a rectangle class that has a number of rows and a columns. Nah, let's not do it for the rectangle. Let's do it for the triangle. We're going to make a print that prints the number of rows and columns for that triangle. So I'm going to go back to the triangle class, and I'm going to write a method called display. It doesn't need to return anything, so it's just void. Void display, parentheses in parentheses, curly brace, and it's going to use a nested loop. For parentheses int r equals 0, semicolon, r's less than this hyphen greater than height, semicolon, this, r plus plus, curly brace, for int c, r stands for row, c is going to stand for column, equals 0, semicolon, c is less than this, dash greater than width, semicolon, c plus plus. And for each element, we're going to just print an asterisk. Cout less than quote asterisk, end quote, semicolon. And after we're done printing all the columns in a row, we need to print out an inline. So after the inner for loop, but before the outer loop ends, Cout less than ENDL. So you see what it's going to do, right? If it's a 10 by 10 triangle, the first row is going to have 1 asterisk, the second one's going to have 2, the third one's going to have 3, the fourth one's going to have 4, and so on. I did that wrong, though. It's going to actually print out a rectangle rather than a triangle. Let's prove that. Let's come down here, and after we create T1 triangle, we're going to call T1.display. Parentheses in parentheses. Let's run it. It's going to be a block. I didn't do it right. Come up here and change it so that instead of this dot width, you know what? We should just delete this. This is didn't work. I goofed it. and I don't even know how to fix it. What we need a way is to calculate the number of columns at that specific point. But what if it's here's what I'm stymied by. It's real easy to print a triangle that looks like this. That's an easy formula to write. But what if it was supposed to look like this? How do we know how many columns it is? That is a 1, 2, 3, 4, 5, 6, 7, 8. It's an 8 by 4. It's 8 tall with the 4. How do we know? How's about we do this? We're going to calculate the width. Int width is equal to this dot, or oh boy, this is going to take a lot of changes. I'm so sorry, guys. Instead of doing r is equal to 0, r is less than this height, make it r is equal to 1. R is less than or equal to this height. I should have done this for a rectangle. It's real easy to print a rectangle. And then int space w equals r divided by this dash greater than height, semicolon, or no, times this dash width, semicolon. And then make this say c is less than w, right there. And we could start our c counter off at 1 rather than 0, in which case we'd say int c is equal to 1, c is less than or equal to w. And if this doesn't work, we're just going to delete it and be done with it. Yeah, there we go. It's a 10 by 10. What if we change it so it's a 10 by 20?
Can you go out 1 second?
Yeah, just a sec. Yeah, that looks like a 10 by 20, right? So this is the end of the inner for loop, end of column loop. This is the end of the row loop. This is the end of the display method. And this is the end of the class. So why not add calls to display the other triangles as well? Let's make a really tall but skinny one. So I'm going to change T2. Don't worry, I'll scroll back up if you need it. It's going to be a height of 20, but just a width of 10, right? It's a skinny triangle. T2 dot display. And then I'll do a walkabout and make sure everybody's going okay. So here's our first one that's wider than it is tall. Here's our second one that's taller than it is wide. I never displayed the third one. Why not display it as well? So T3 dot display. And there it is. 30 tall, 30 wide.
Big triangle.
We've done a loop that calculated a total. Let's do another one. Let's calculate the total of all the numbers between 100 and 1,000 if they're divisible by 25. So we're going to create another variable called total. We're going to set it equal to 0 so that we can start adding to it. Calculate the sum of all numbers between 100 and 1,000 that are divisible by 25. So I'm just going to set up a for loop that counts from 100 to 1,000 and it increments by plus equals 25 each time. for int I is equal to 100, because that's the starting point. I is less than or equal to 1,000. I plus equals 25. And we're going to add that to the total. Total plus equals I. And we can do that. Cout less than total calculated equals space in quote less than total less than ENDO. Now we're not saying what total, right? But whatever. I don't feel like writing all of that and pasting it in there. So up at the top, we'll see that the total calculated was that. This is called a running total, a running tally. Why do we have two Visual Studio Start pages going? Alrighty, go away.
No, wait.
Are we good to go on this? Okay. Sentinels. We've been using Sentinels for a long time, like -1 to quit. It's a special value that indicates the end of the data. It needs to be something that cannot be confused with a valid piece of data, right? Like you can't have a negative pay rate. So -1 is a safe Sentinel value. Would we want to use 0 as our Sentinel value? No, because you could work 0 hours this week. So that would be a bad Sentinel value. When do you use it? When you don't know how many pieces of data will be entered. Now there's another way you could do it. You could just ask them, do you wish to continue? Right. Same kind of idea, but it takes 2 keystrokes, right? They have to enter a value and then they have to type yes for I wish to continue. It's better if you just let them type in a number, type in another, and then -1 to quit, or whatever the Sentinel value is.
Do you want to continue? Press
Yep.
where and the answer.
So which loop should you use? Use a for loop for counting. Situations where the number of iterations is known. Use a do loop when you need it to always iterate at least once, where you have to have the body execute at least one time. Use a while loop in any other case. Validating input, reading lists of data terminated by a Sentinel, iterating as long as a certain condition exists, not exits, exists. So I'm going to rewrite this a little bit. I guess I'll add it straight to the C++ code. Use a for loop when you need a counter or to step through a specified series of values. Use a do loop if the loop needs to iterate at least one time. The body needs to execute once. Otherwise, use a while. Like Sentinel loops or validating data.
Or an error check.
Yeah, error checks, things like that. Okay. So pre-test loops, for and while. Post-test loops, not post-test loops, or do. All right, so right now our program's making us enter data no matter what, right? Every time we run it, we have to enter some data. We're going to get a little bit sophisticated here, and we're going to use preprocessor definitions. What we're going to do is we're going to say $define triangles space true. And we're going to do $define payroll space false. Then I'm going to come down here, and inside of main, before my triangles code, way down here, before int triangle, we're going to do pound sign, or no. I kind of botched this. Go back up here and just do pound sign define triangles and pound sign define payroll. Take off that true and that false business.
Because that would be too hard.
And then down here, inside main, above triangle T1, do this. Pound sign if def space triangles. And then it's complaining that we don't have an indif. So the last thing to do about triangles, the last reference to triangles is down here, add pound sign indif. Now we're going to do the same thing for the paychecks. That variable was called payroll. So pound sign if def payroll. And then scroll down to the bottom after the payroll stuff, before the pause. Pound sign indif. These are called macros, or preprocessor commands. And you can use it to change how your code is compiled. Right now it's still doing everything. But if I come up here and I comment out the triangles, if I comment that out, it's no longer going to do the triangle stuff. Right? Didn't do anything with the triangles. If I uncomment that out, but comment out payroll, it does the triangles, but it doesn't do the data input. You can do strange things with these macro definitions as well.
Like
What do I mean by that?
Can you go back to the if this again?
Mm-hmm. Which? Yep. Pound sign if def triangles goes above triangle T1. And then underneath all the triangle stuff, it'll be pound sign indif. So down here, after the last cout triangle, do pound sign indif. We may as well make that a comment, but I'm not sure about that.
That's a lot of sophisticated stuff in here. Oh, what happened to the... Why is it translucent now?
Because payroll is no longer defined. So that code is no longer included in our project.
So if you take it out, it's not...
Well, we're not going to delete it because we might want it later, and if we did, we would go and make it real again, right? If I wanted to do the payroll stuff, I'd come up here and I'd remove that comment. Like that. So let's define what our overtime bonus is. Pound sign define overtime underscore bonus 0.5, right? 50%. But maybe we are really mean and we don't want them to get a bonus at all, right? And so in which case we change it to 0. So down here in our calculate payroll formula, go down here, and where it says divided by 2, take that divided by 2 business out and make it times overtime underscore bonus. So if you needed to edit this program really fast and change the overtime bonus, you could do that, right? So these are macros, and you can do strange stuff with them. Like say that you hated the word int. This is stupid, and we would never really do this. But define int, wait, define goober space int. Now I can come in here and change every int word to goober. Now, am I going to keep this change? No. No, I'm not.
I think your boss would fire you if you did.
Yeah, exactly. Right. I'm I'm writing my own language. It's kind of stupid, right? But you can do that with C++. You can't do it with Java or Python or anything, but you can with C++. All right, now I'm going to get rid of that. That's silly, right? But
I mean, yeah, if it looks too stupid, I mean, it'll make you look unsophisticated. That's the point, right? I mean,
yeah. And so back in the old days, before there was a Boolean type, people would do this. # define Boolean to mean int, # define true to be 1, and # define false to be 0. And then their code would look like this. I'm probably going to delete those 3 lines. But you might create a Boolean variable like error, and it's equal to false. And then later on, you might set it equal to true, right? People did that before there was a bool data type. So they wrote their own data types using # define. Yeah, let's get rid of those though. So nested loops. We've seen nested loops. A nested loop is when you have a loop inside of a loop. Like if we want to print a multiplication table. You have a row calculator, you have a column calculator, and tell me that we've already did this. Have we printed out a multiplication table where we did the x and the y? Okay, let's do a multiplication table. So down here in main, above everything, we're going to print a 10 by 10, let's just do a 5 by 5 multiplication table. So # define rows 5, # define calls 5. Now for parentheses, int r equals 0, semicolon, r less than rows, in all caps, semicolon, r plus plus. Whoops, there was supposed to be a semicolon there. But let's start it at 1, right? We want to go 1 to 5 rather than 0 to 4. So I'm going to make that start at 1 and count to less than or equal to rows. I just changed that. And for int c equals 1, semicolon, c is less than or equal to calls, semicolon, C++. We're going to cout less than r times c less than quote \t. The backslash is above the enter key. And then after our inner for loop, this is a nested loop, we're going to, after we printed every number in that row, we need to print out an ENDL. Cout less than ENDL. That'll print out our little multiplication table. And if we scroll up, we'll see it, right? 4 times 2 is 8. 5 times 4 is 20, and so on. It just used a nested loop. So we've done nested loops twice now. We did a nested loop to print out a multiplication table. We did a nested loop to print out our triangle. The inner loop has to complete completely before the outer loop executes again, right? We got to print every triangle in that row before we can print an ENDL. So all the asterisks are printed inside the inner loop, and then the ENDL is printed outside the inner loop. Same with the numbers. All of the multiplied numbers are printed inside the inner loop, but then we go to the next line, like hitting the enter key, outside the inner loop. And that's what we see here. Right? We print out the multiplication, or we print out the entire row of the entire row of asterisks. And then outside that inner loop, we go to the next line. Or here, where we were printing our multiplication loop, we print all of our multiplied numbers and tabs. And outside the inner loop, we print the enter key, the ENDL. So this loop has to complete all of its executions before the outer loop can go one more time. So the inner loop goes through all the repetitions before the outer loop can iterate again. The inner loop completes sooner than the outer loop, right? Because just like when we ran it, this inner loop had to print all the numbers it completed first, and then the outer loop was able to iterate once. So how many things do we print? The number of iterations of the inner loop times the number of iterations of the outer loop. So we just printed out 25 numbers because we had 5 columns and 5 rows. Using files for data storage, that's a different topic, and we're going to stop here. Yeah, but we have 15 whole minutes.
How about pass out early?
Let's do just a little bit about files.
We tried.
We're going to write some output to a file.
We tried.
Going to write some output to a file. I don't know what the output's going to be. Maybe it's just going to be a single word. So up here at the top of main, we're going to create a file variable. But firstly, we need to modify this to include. You know what? Let's just stop. Yeah, we stop. We pick up the topic of files because we haven't even made any homework over this. Although, what kind of homework could we do on it? I've had y'all do several classes in here, but I'm kind of shy about making y'all do a class as a homework yet.
Well, why don't we why not do a homework that has classes?
Yeah, let's do a homework over classes. It's going to be a really simple one, and in fact, we may have had an example of this in the past, but here's what our homework's going to be. Write a class named Circle. The class has one public variable called radius. One public variable named radius, which is going to be a double. The class has 2 methods. Get area returns the area of the circle. Get diameter returns the diameter of the circle. The formulas are area is equal to pi r squared, right? So m underscore times POW radius to the power of 2. And the circumference is just 2 times the radius. No, excuse me, the diameter is equal to 2 times.
Will this be on the homework sheet?
Yeah, of course this is going to be uploaded as homework. You don't have to type it online. All right, so your program should create 2 circle objects, just like we did 3 triangles, and print out the area and diameter of each one. Set the radius of the first one to 2. Set the radius of the second one to 10. Yep, this is our homework assignment. Now, it's possible you're going to need help on this because we haven't hit the PowerPoint over classes. However, we've done classes like in 4 lectures so far, so this should look familiar. In fact, we may have even done a circle class in the past, but try to write it again. We have our example from a triangle. Use the sample triangle code we did in lecture. All right. Make sense? Parker made y'all do it, so everybody blame him. No, I'm kidding. I'm kidding. This is valuable experience. So let's stop here.